So far in our previous lessons, we have seen how to work with pointer variables. So we pretty much understand the basics. In this lesson, we will write some more code using pointers, and we will look through some of these concepts in more detail using some examples. The first thing that I want to point out is that pointer variables are strongly typed. What it means is that you need a pointer variable of a particular type to store the address of a particular type of variable. So int star or a pointer to integer will be needed to store the address of an integer. Character pointer will be needed to store the address of a character. And similarly, if we have a user defined structure or class, then we need a pointer of that particular type only. But why do we need these strong types? Isn't it that the pointer variables just store the address of the variable? So why couldn't we have just one type that will be some generic type to store the address of all kind of variables? And the answer is that we do not use the pointer variables only to store memory addresses, but we also use them to dereference these addresses so that we can access and modify the values in these addresses. Now, as we know, data types have different sizes. Like in a typical modern day compiler, an integer is stored in 4 bytes. A character variable is stored in 1 byte. A float is again stored in 4 bytes. And these variables differ not only in their sizes, they also differ in how we store information in whatever bytes are available for these variables or data types. Let's say we have an integer a and its value is 1025, and this is how it is laid out in the memory. Each bracket here is 1 byte. So let's say this particular byte, which is the least significant byte, is byte 0, and then we go on like byte 1, byte 2 and byte 3. Now we also know that each byte in the memory is addressable. Let's say the address of byte 0 is 200. Now these 4 bytes need to be contiguous. Let's say the address of byte 1 is 201, and then we go on like 202 and 203. When an integer is represented in the memory, is stored in the memory, the leftmost bit stores the information that whether this integer is positive or negative. So this is also called sign bit, and rest 31 bits are used to store the value. So if you see, we have a 1 at rightmost bit with place value 2 to the power 0, and at this particular bit with place value 2 to the power 10. So the overall value that we have in binary here is 1025 in decimal. Now what if I declare a pointer to integer p and store the address of a in p by using the ampersand operator? What will happen if I print the value of p? The value of p, or the address stored in p, will be 200, the address of byte 0. So we are kind of saying that we have the address of an integer variable starting at address 200. If we dereference this address and try to print asterisk p, we want to know the value at this particular address, then the machine sees that okay, p is a pointer to integer, so we need to look at 4 bytes starting address 200, and then the machine knows that how to extract the value of an integer data type. So it retrieves the value 1025 out of these 4 bytes. Now if p was a character pointer, then while dereferencing, the machine would have looked at only 1 byte, because a character variable is only 1 byte. If p was a pointer to float, then although float is also stored in 4 bytes, but the way information is written for float in these 4 bytes is different from the way information is written for an integer data type. So the value printed would have been something else. Let's go write some of this in a real program and see what happens. In my C program, I'll first declare an integer a equal to 1025, and now I'll declare a pointer to integer p, and then I'll store the address of a in p by using the ampersand operator. Now I'll write a print statement like this: size of integer is, and we have a function size of in C which gives us the size of a particular data type in bytes. And now I'll write a print statement like this: address is equal to p and value is equal to asterisk p. We dereference p to print the value. Now let us see what is the output of this program. No points for guessing. This is pretty straightforward. The size of integer is 4 bytes. The address that we are showing here is some address, and the value is 1025. Okay, now I'll do some trick here. I'll declare a character pointer. Let's say the name of the variable is p0. Now I'll try to put the same address as we have in p into p0 by writing a statement like this. But this will give us a compilation error because p0 is a pointer to character and p is a pointer to integer. So what we will do here is we'll typecast p to character pointer and then assign the value. And now I'll write two more print statements. First is size of character is these many bytes, and we use the method size of again. And the second is the address is p0 and the value at address is asterisk p0. So we try to dereference p0 now. And let us see what's the output now. The first line of output is size of integer is 4 bytes. Address, because we are running the program fresh, this address will not be the previous address, the address from the previous run. This will be a different address. By dereferencing the integer pointer, we are getting the value 1025. Now the next line of output is size of character is 1 bytes. Address is 5373032, which is the same address as we have in the second line. But the value this time is 1. Now why is this value 1? Once again, if we write 1025 in binary using 32 bits, then this will be the representation. When we do this typecasting here, trying to store the address of p in p0, then the address of this particular byte, the rightmost byte, is stored in p0. But when we dereference p0, because p0 is a pointer to character, the machine says that, hey, this is a pointer to a character and the character is only 1 byte. So I'll look at only 1 byte to see the value. And if you see, this particular byte in binary is 1. And that's why this output here is 1. Okay, I'll write two more print statements now. One to print the address p plus 1 and the value at address p plus 1. Now as we know, we can add or subtract an integer constant from a pointer variable. This is allowed. In fact, the only pointer arithmetic that is allowed is adding or subtracting some constant integer value to the pointer. P plus 1 will take us to the address of the next integer. So it will skip 4 bytes and take us 4 bytes ahead. Let's say we also want to print p0 plus 1 and the value at p0 plus 1. Okay, now let's see the output of this particular program. The address of A this time is 4456036. That's what is allocated for A in this particular run. The value is 1025. P plus 1 is 4456040. If you see, this is 4 bytes more than the address of A, because size of integer is 4 bytes and P is a pointer to integer. So incrementing P takes us 4 bytes forward. And this value is some garbage value because we have not filled anything in this particular address. So there is some garbage in the memory which we are picking up. Now the address in P0 is also 4456036, which is the address of the first byte, the least significant byte of A. The value is 1. Now P0 plus 1 is 4456037. Here we have a value which is 1 byte more, and this is because character is stored in 1 bytes. Now the value here is 4. If you see, P0 plus 1 will take us to this particular byte, the address of this particular byte, and this particular byte in binary is 4. This was to show you how things happen in memory when we dereference a pointer variable by using the asterisk operator, and also what happens when we perform pointer arithmetic with a particular pointer type. This typecasting of pointer variable from one to another also has some use cases. We will discuss them later. Now we will discuss one pointer type, which is generic pointer type. It does not correspond to a particular data type, and this pointer type is called void pointer. And we declare this particular pointer type by using the keyword void and using an asterisk sign in front of the variable name. Okay, now we can write something like p0 is equal to p. We do not need an explicit typecasting here like this. The statement p0 is equal to p is valid, and this will not give you compilation error. And because this particular pointer type is not mapped to a particular data type, we cannot dereference this particular pointer variable. So if you try to print star p0 or asterisk p0, this will give you an error. We are getting a compilation error. We can only print the address, and as we can see here, the address is same as the address of A. And if we perform arithmetic, if we try to do something like p0 plus 1, access something like p0 plus 1, this is also not possible. This will also give you compilation error. We will come back to the use cases of void pointers in forthcoming lessons. Let's for now know that there is something called void pointers. So this was diving deep into pointer types, typecasting, and pointer arithmetic. We will have a lot of fun with pointers in the coming lessons. So thanks for watching.